Today's video starts on page 8, and we're going to talk about some algebra and some vocabulary, terms of an expression. So terms are parts of a math expression separated by addition or subtraction signs, like 3x plus 5y minus 8. It has three terms. It has a 3x, a positive 5y, and a negative 8. Like terms have the same variables to the same powers. So an x and an x squared are not like terms because one has a power x, has a power of 1, and x squared has a power of 2. Which are like terms? 3x and 7x. They both have the variable x to the first power. They are like. 5x and 5y, not the same variable. One has an x, one has a y. They are unlike. X and x squared, like that example that I said, are not the same. That's x to the first on the left, and x squared, that has a different power. They are unlike. 6 and 10 constants, number constants, are like. We can combine them. 6 plus 10, or 10 minus 6, or 6 minus 10. They can combine. They are like. Like things can combine. Coefficients. A coefficient is a numerical factor. So coefficients is a fancy word for factor. The coefficient is written in front of the variable. So numbers come first, then letters of the alphabet. The example, 6x. 6 is the coefficient. It's the numerical coefficient. X is the algebra, or the variable. So 6 is the numerical coefficient of the term 6x. Write a math expression for each situation. So on the left here is 3 cats plus 4 more cats. 3 cats plus 4 cats, I can put them all into one group and call it 7 cats. I can combine those because they are like. 3 cats plus 4 cats can make a whole group of 7 cats. What about subtraction? I see on the left here 8 apples minus 1 apple. Yes, I can combine that. If I have 8 apples and I take away an apple, I have 7 apples. So 8 apples minus 1 apple, and I could say 8a minus a and not have that 1 in front of it because it means the same thing. 8 apples minus an apple gives me 7 apples. Those terms can combine. So yes, like terms can be combined to show subtraction. Addition and subtraction. You can combine like terms by adding or subtracting, because adding the opposite is subtraction, so it's adding their coefficients. So the numbers out front, follow the integer rules and combine them. Same signs add and keep, different signs subtract. So let's combine like terms. 3x plus 8x, add the 3 and the 8, and you get 11x. Not 11x squared. We are not multiplying x times x. That would be x squared. We're just adding the coefficient 3 and 8 and getting the 11x. Combining like terms. We're simplifying that expression. Oh, here we have 3 terms. 7x plus 5x plus 2x. So 7 plus 5 plus 2, I'm associating them or undistributing them from the x. I'm using really the distributive property. 7 plus 5 plus 2 is 14. Put the x on the answer, 14x. 10x, take away 4x. I can combine the 10 and the 4 by using the distributive property. I can do 10 minus 4 first, and then multiply by the x. That's the distributive property. So 10 minus 4 is 6, 6x. 3x x plus an x, remember that's like having 1x, so 3x plus 1x gives you 4x. When there is no number written in front of the variable, its coefficient is 1. So x is like having a 1x in that last example. Let's try another one. Okay, so we have 5 cats and 4 dogs. Are those like things? No. So we can't put them all or combine them into one group and call them one thing, because they are not like things. 5 cats and 4 dogs cannot simplify. C is not like D, so you cannot combine them. So if you think of, and I do this when I'm thinking about like terms, I think of a picture or an animal or a food, like apples or xylophones for X and yo-yos for Y. And X's and Y's, xylophones and yo-yos can't combine. Well, cats and dogs can't combine. Apples and oranges. So we have 5 apples, take away 4 oranges, but they're calling it B here. I would think that should be an O, okay, but that's not bananas. So 5 apples, take away 4 oranges, I can't combine that. I can't call it one answer. No such thing as an apple-orange, for instance. So these cannot simplify. This expression cannot be simplified. I cannot combine them together because they are not the same letter of the alphabet. Apples are not oranges, or bananas if it was supposed to be bananas. So you can only combine like terms, and you can never combine unlike terms. So put a visual to the letters if you need to say, oh, are these like or not? So in the examples, simplify or combine like terms. Simplify means to combine the like terms. So I have 3x and 2x. They can go together because they're both xylophones. 3 xylophones and 2 xylophones gives me 5 xylophones. But those 6 yo-yos cannot combine with the 5 xylophones. So this 2-term expression here, it's called a binomial. That's as simplified as it gets, 5 xylophones plus 6 yo-yos. In the next example, the only thing I can combine here is the 1x and the 2x. 1 xylophone plus 2 xylophones is 3 xylophones. That constant 7 doesn't have an x on it, can't combine. So I can't call that, for instance, 10x. No, no, no. That 7 does not have an x on it. 8x, take away 3x. So 8 xylophones, take away 3 xylophones gives me 5 xylophones. And again, that 10 cannot combine with it because it doesn't have xylophones on it. And the last one here, oh, we have xylophones and yo-yos. 4 xylophones does not combine with 5 yo-yos. No, no. But 4 xylophones can combine with 3 xylophones to give me 7 xylophones. And 5 yo-yos take away 2 yo-yos, or 5 yo-yos combined with negative 2 yo-yos, you could look at it that way, gives me 3 yo-yos. So this simplifies to 7 xylophones and 3 yo-yos. Cannot simplify any more than that because yo-yos and xylophones can't go together. And now it says turn over your paper, but no, we're going to turn to the next page. Next page, simplifying variable expressions. As you saw in that PowerPoint, we went over some of this vocabulary, have a couple more things to add on, and we simplified or combined like terms. A term is a part of an expression that is made up of both numerical and variable factors. Each term is separated by an addition or a subtraction sign. Addition or subtraction sign. Numerical coefficient, a number that is multiplied by a variable or a group of variables. So it could be something like 7a or negative 6xy. Like terms are monomials, single terms, that have exactly the same variables to the same power, meaning exactly, same variable to the same power. That's what exactly means. simplifying an expression, rewriting an expression without parentheses, and combining all the like terms. Polynomials are a string of monomials. Monomial is another word for term. Is a string of terms connected by a plus or a minus sign. So a constant is a number without a variable. A monomial is a one-term thing. One term. So you could also say term is also called a monomial if it's a single term. Binomial has two terms in it, and a trinomial has three terms. So a monomial could be something like 7x, or it could be negative 15. It could be just a constant number, or it could be 3y. A binomial is something that has two terms that are not like 7x plus 6, or negative 3z's minus 8. And a trinomial, which we saw in the last presentation, is similar to this one right here. That's a trinomial because it has three terms in it. So this one has three terms in it. What are like? It does have some like terms in it, the 5b and the negative 3b. Those are like terms. The numerical coefficients in this trinomial, so I'm going to go ahead and fill that in down here. It has three terms on it. This a has a 1 in front of it. Remember, if it's not there, it's really a 1. B has a 5 in front of it, and the last one has a negative 3 in front of it. So those are the numerical coefficients, the number coefficient out front. In this next polynomial here, we have a 10xy, 5y, plus xy, and negative 13. It has 1, 2, 3, 4 terms. What are the like terms? Well, we have 10xy and xy, which is really 1xy. 5y is not like 13, so no other like terms. The numerical coefficients, I see a 10, a 5, a 1, and we don't call negative 13 the constant. It's not a numerical coefficient because it doesn't have a variable on it. That's just the constant. What type of polynomial is it? Well, once you get past 1, 2, or 3 terms, 1 being monomial, 2 being binomial, 3 being a trinomial, we just call them poly, meaning many terms. Polynomial. So simplify each expression. Name the property used to help you simplify it. Oh, okay, so I'm going to use some properties here. Yes, you really do use properties. 6 yo-yos plus 8 yo-yos. I'm really going to add the 6 and the 8, right? I'm going to combine those numerical coefficients and call it 14 yo-yos. Well, what allows me to do that is what's called the distributive property. I'm taking the y that's constant in both of them, it's in each of the terms, and I'm undistributing it, basically, putting it at the end. So 6 plus 8 would give me the 14 y's. You're really using properties. We don't talk about that a lot when we're combining like terms, but that's what we're doing. Simplifying this expression, 3 times 8y, well, I'm going to multiply the 3 times the 8 to simplify that. So I'm using the associative property. I've moved the parentheses. That's the associative property. Oh, let me tell you what the answer is first. Simplified, that would be 24 y's. And that's the associative property of multiplication, by the way. So I'm going to put that in parentheses. And I multiplied to get that. I'm going to use the associative property for addition here because 9 and 12 can be combined. They're like terms. They're constants. So my 5t will stay 5t's. It doesn't have anything to combine with. And 9 and 12 makes 21. And again, I used the associative property, and I'm going to abbreviate that. Only this time I used the associative property of addition. In number 4, 8 zebras and added to negative 15 zebras, not possible, but I'm just going to say that. If I take out the z that's common to both terms and add, or different signs, subtract. Subtract those numerical coefficients because they have different signs. 8 take away 15 gives me -7 z's. Again, I'm using the distributive property here to put these together. -7 and 12 are constants. I can put those together, so I'm going to move the parentheses there using the associative property. Different sign, subtract. 12 take away 7, I get 5 and 8y's. Now that's not good form. You always want to have your algebra term first in your binomial, this two-term thing that I have here. So I'm going to put my algebra term first, and I used the associative property. I'm going to abbreviate that again, of addition to put that together. Number 6, I'm going to multiply. And first I'm going to multiply my -6 times my -5. 2 negatives makes it a positive 30g. And here I'm using the associative property of multiplication. And that's it for today's video.